Hi, I'm Susanna Gordon, and this is my video for Lab 1 for Physics 2112 with Professor Yunker. So, basically, the whole point of this lab was we were charging tape. So the whole process would be you would put tape down on a flat surface, put tape on top of it, and you would rip it apart. And when you would do that, the electrons from the upper tape would be left on the lower tape, leaving the upper tape with a positive charge. So if you rub a pen in your hair and that gains a negative charge and hold it near the tape is going to try to go near the pen. And this is a very interesting process, and then we did it with two different tapes. And if you brought them near each other, they would repel from each other, proving that they are both positive charges and are both repelled away from each other because they are like charges. In the experiment, we needed to get different measurements in order to calculate the electric force. So basically what we did was we set one tape suspended above the other, and then we were calculating the distance between them to figure out the attractive force, because the upper tape would bend away from the lower tape to get away from it. And that means if you draw a force body diagram, that the gravitational force acting on the upper tape has to be equal to the magnitude of the electric force, because gravity is acting downwards and electric force would be acting upwards, and since it wasn't moving, it's in equilibrium, so therefore they must equal each other. So first we got the length of the tape, which we said was 0.2 meters, so 20 centimeters. The mass of the tape was 0.2 grams based off of what was given to us in the lab, that for about every centimeter it's 0.01 grams. And then for the distance, we calculated to be about 0.2 meters, so this could be a bit give or take because it's a bit hard to try to find the exact distance between them. And then to calculate gravitational force, we did mass times gravity. So we did 0.2 times 0.2 grams, but then we converted it into kilograms to be in standard SI units. And we got the value of 0.00196 newtons. And then because we know the electric force has to be equal to this, it is also 0.00196 newtons. Alright, so this is the code that I made for this, and I have a screenshot of the model on the next slide. But basically what I did is I did what we used in Lab 0, where we created a function for E field, and I basically made it to calculate the direction of the electric field based off of the point charges, as you can see, where I have the magnitudes of R and also the direction of R to help figure it out, and I would print out a vector in that color. And then I also calculated gravity based off of the same equation I used before, m times g. And then I did the electric force is equal to gravitational, and I had it so you could see it on both of them with the forces acting on it. So this is a screenshot of my model. So the tape is represented by these red spheres, and they are 0.2 apart from each other, basically, and the size of the spheres is irrelevant. It's just supposed to be a model of what we were looking at. And then that purple arrow is the electric force vector, and that cyan or light blue arrow going down is the gravitational force on it. As you can see, they are equal, but we have assumptions in this, such as the tape is a point charge, which is why it is demonstrated by a sphere, and also that it's an evenly distributed charge on the tape surface. So that's why we're able to make this simple model representing that. And then lastly for this lab, we had the final questions. So the first one is, what if electrons had a positive charge and protons had a negative charge? So electrons and protons, the reason they have a positive or negative charge is very subjective. That's just what we assign to them. So if you switched their charges, it's not going to affect your results. Even if you said that electrons were positive and stuff, that would just change that you would say that the tape would instead had a negative charge rather than positive, but they would still repel from each other and you'd still have the same effects of the experiment because we chose those charges, and that's just the way we view it. So changing the value of them is not going to change the results of the experiment. And it's also important to handle the charged tapes as little as possible for question 2, because if you touch it, the electrons from your hand will jump onto the tape, and then it will neutralize the tape, so it will no longer be attractive or repelling to any other charged objects. So that's why you have to be very careful when handling the tapes and make sure you don't touch it. Anyway, this is my lab video, and thanks for listening.